Welcome back. Myself Farsana. So far in computer vision track, we discussed about how system will read and understand images. Also, we learned pre-processing technique. In addition to that, we saw what the challenges we have when we work with fully connected neural network and the reason why we move forward to convolutional neural network. We did a practical demo on fully connected neural network using text analysis to understand the concept. So please do check to understand the process. Today we are going to start with a practical session on a multi-class classification using convolutional neural network for grayscale images. I am separating this session into different parts. In part 1 we focus on data loading and data preparation. But before we dive for today's session, if not yet subscribe my channel, please do support by subscribing. If already subscribed, please hit the bell button so we will not miss the next videos. Now, let's start with simple data set which helps to understand and implement the process on a convolutional neural network. So today dataset is all about MNIST fashion dataset. It's a grayscale image. We will start analyzing these images parallelly while implementing the coding. So the first step is to implement the necessary libraries for today's session is NumPy matplot library, and here I am going to import the dataset using tensorflow.keras.dataset, and the dataset name is fashion MNIST dataset. So this is the other way of loading the data. To load the data, next step is loading the data. For that, we have to pass the dataset name is fashion underscore MNIST dot load underscore data. Xtrain, ytrain, xtest, ytest is the variable. It can be any variable, but it's good practice to go with this variable. The next step, we will print the shape of this variable. I am using Kaggle. If you are good to go with Google Colab, yes, please go with Google Colab. The syntax is going to remain the same. So for Xtrain, it contains a total of 60,000 images of shape 28 of 28, and for ytrain it's just 60,000. Why? Because it's not images, it's just a label. And for xtest it is 10,000 images of shape 28 of 28, and for ytest it is 10,000 label. It's a 10 class classification, so we have a label between 0 to 9. What is 0 means? It's a t-shirt or top. What is 5? It's a sandal, and 9 it's an ankle boot. So we want to copy this label. So what I'm doing, I'm passing this label to the local variable class underscore name. To find the count of this, just pass len of class underscore name. So it gives a total count of 10. Now let's display single image and check about the images. So I'm passing 5000 and it's a gray image, so I'm passing CMap. To display the image, pass plt.imshow. For the label, again I'm passing ytrain of image, so I'm passing to print this, pass print class name. So what does this class name contain? Our label name. So here I'm printing this 5000. So the output is, it says that it's a label 4. Label 4 belongs to quota. So what I'm going to do is, again if I want to change dynamically, means it's very hard to change in multiple places. So I'm passing a local variable index is equal to 50,000. So I'm passing this index in all these places. Okay, it's like a constant. Sorry, I'm passing over here in all these places, so we can change it dynamically in one place. So now I'm going to check what is this 50,000. It says that it belongs to a class 9 of ankle boot. Instead of directly jumping to build the model, we need to spend time by analyzing the data. So now let's visualize few pics. So what I'm going to do is, I'm going to visualize a pic. Okay, here figure comma axis. So I'm going to plot it between 10 rows and 5 columns. So totally I'm going to display 50 images. Okay, so let me execute this one. So here I am passing CMap equal to gray. The reason is it will expect always a color image. The CMAP will expect always a color image, but now I'm going to tell the system this is not a color image, it's a grayscale image. So we have to manually pass this one. CMAP equal to gray. If it is a color image, it is not necessary to pass this CMAP is equal to gray. Here all these axes are on, so what I'm going to do is I'm going to make this axis off. So I'm passing ax dot axis as off, so this axis will get removed. From this we can clearly say that all objects are properly aligned in the center of the image frame. The background is black and almost all images are whitish except few images are in black color. See here, this dress t-shirt looks similar and this coat and pullover also looks quite similar. So the model may or may not get confused. So we will analyze. So these are all the basic analysis to be done manually by going through images. Also ensure test data is not that differentiate from the training data. This is why performing general analysis is important in machine learning, computer vision, NLP, whatever it is. So we have to spend time on exploring data, understanding data, identifying common challenges, identify strength and the weakness of data. Once we are done with this, later when it's come to hyperparameter tuning and performance analysis, we will be in a better position to take a decision which help in optimizing the model much faster. So this is very important step which will take time to understand the data. So now we are done with the first stage, nothing but the data loading or data collecting. The second stage is data preparation. So as a part of data preparation, we may want to prepare on both features as well as labels. So are you ready to go for the second stage? I hope the first stage is all clear and set to go. I am going to print the shape of X train and Y train. So here we see that 60,028 of 28. The images are in the form of rows and columns. See here, if it is in the form of color images means we would have channel. So how it will be? So if it is a color image means 60,000, 28, 28, 3. This 3 is nothing but the channel. We say that it is a color image, but in our use case this is not there because it's a grayscale image. So this is the 4-dimension which is the standard format and the system will expect the standard format, but now we have only 3-dimension. So the system will be in the expectation of row, column and channel. But in gray image we don't have channel, so we need to reshape the images as one for gray images. So if it is a color images means then we don't want to do this step, okay, but since it is a grayscale image I am going to reshape it. So now the next step is reshape the image data to convert into channel format. 68,000 of 28 of 28 of 1. Why 1? Because it's a grayscale image. So once when I print this shape of this X train and Y train, see we want to change not only for training image, parallelly we want to do it for test images also. So 10,000 images of shape 28 of 28, I am going to add 1 over here. The next step is we are going to print the shape. So now it got reshaped to 68,000 of 28 of 28 of 1 from 68,000 of 28 of 28. So now we are done with reshaping the format as per the expectation of the system. The next step is scaling the data. This is done to bring between 0 to 1. So initially the pixel values are between 0 to 255. Why between 0 to 255? Already we know that, and we discussed in our earlier session, all ranges between 0 to 255. So 0 refers black, 255 refers White in between, or is a combination of RGB which lies between 0 to 255. Now once we done this, the pixel value from 0 to 255 it got down to 0 to 1, and this scaling is very important not only in computer vision, even when we work with NLP or machine learning model, we all done with the scaling. So x train is equal to x train by 255 and x test is equal to x test by 255 because the maximum value is 255. So if it is for black means what will be the value? Minimum value will be 0, and white is the maximum value is 255. So 255 by 255 will be 1, and for the remaining value is between 0 to 55, so it will range between 0 to 1. So the next question will be from your end, whether this change the content of image. No, this will not change the content of the image. The image is going to remain as it is, only value is going to change. So no content is going to change or any change in visualization part. So why to worry on that? Let's visualize it. See here, so there is no change in the visualization of the pic. Okay, so this is an ankle boot remaining same even once we are done with the scaling part. Next step is one hot encoding of label. This is the last step of data preparation. Let me execute this white train dot shape and white test dot shape. So it has only one value of 60,000 and 10,000. Let me execute this white train. Here we have set of values, so that what we are doing one hot encoding, which means we need to convert them into 60,000 rows and 10 columns. So why 10 columns? Because it's a 10 class classification. Why we need a one hot encoding in neural network? We have 10 types of class classification problem. So how many neurons we have in output layer in neural network? We have 10 neurons. The number of neurons in the output of neural network is equal to number of class, except two class classification, because two class classification can be done with one neuron also. Either we can go for one or we can go for two, but more than two class classification, it is must that how many classes we have, that many neurons we should have in the output layer. So here we have 10 class classification, so the output should contain at 10 neurons. Let me execute this step. So I am importing the one more library, tensorflow.keros.utils, import to categorical for the dump. So let me execute the steps again for this. Okay, see, initially we had only one value, which is a 60,000 rows and 10,000 rows. Now we have a 60,000 rows and 10 columns. What does this 10 columns is that? It's a classification, okay, a 10 class classification which contains a label, okay, and parallelly for white test means 10,000, even we have a 10 class classification. To understand better, I am going to display with a single value of white train of 50,999. See here it says label, it has only one value, all other values converted to 0, so which belongs to 0, 1, 2, 3, 4, 5. So the label 5 belongs to sandal. The next step is I am going to display the whole of y underscore train. See, now it says that it contains a 60,000 rows with 10 columns. So this is what about for the today's session. So we are done with the data preparation and we covered 3 steps: reshape images to standard format, scaling of images, and one hot encoding of labels. I hope the content is really useful. If you like this session, please do like, share and subscribe. Any input or suggestion, please do comment in the comment box. Thank you. Catch you soon in the next session. Till then, Farsana signing off.